So our next presentation, excuse me, comes from Mahlet Melaku from Ethiopia. And Mahlet is a faculty member in Addis Ababa Institute of Technology, School of Civil and Environmental Engineering, with research interest in affordable and sustainable sanitation. And her presentation is on nutrient recovery as struvite, the case in Ethiopia. Please take it away.
Can you see my presentation?
Yes, looks great.
Okay, thanks. So I'll first start with by introducing my research colleagues. The first is, which is the PI, is Dr. Ade from the Biotechnology Department, and all others from the School of Civil and Environmental Engineering. So as an introduction, I'll start with our motivation to the research. So the first one, we had two issues. The first one is there is still a demand of fertilizer, escalating demand of fertilizer. And the other one is sanitation facilities are still in planning stage in our country, in Ethiopia. According to the Ministry of Agriculture here, even though they are investing almost 2% of their GDP for importing fertilizers, they couldn't even address more than half of the farmers' demand. So we thought we can assess urine diversion facilities for fulfilling these two demands. As nutrient recovery can easily be adapted without any cost of retrofit because we don't have the sanitation facilities at hand. So we expected from this research, we can alternatively substitute the chemical fertilizers with struvites. So as most of you know, struvite crystallization is not a new thing. It has been going on through the academic world for decades, and it has been mostly applied method. But what we were interested in was to work on the kinetics and mechanism of struvite precipitation so that we can supply or we can add data for the design of efficient urine treatment process. So the basic objective was recovering phosphorus, nitrogen, and or potassium through crystallization of struvite or potassium struvite. So what we did, the method, was first collecting the sample. So collecting the sample was done at large public events. Whenever there were soccer events or concerts, we were there to collect the urine. And we stored it for 3 weeks, a minimum of 3 weeks, up to 3 months, depending on the sample. And the magnesium source used was magnesium chloride. Then a jar test was carried out. So through the jar test, we tried to find the most efficient, the most optimum pH, dosage, and mixing time. So for both struvite and potassium struvite, we followed this step. But in case of potassium struvite, we needed first to treat the ammonia. So for that, we used ammonia stripping method, which is constructed in our lab. So it's a packed column filled with rings, not more than 30 millimeter. The column itself is a GS pipe, the pipe with a pipe diameter of DN 160. The effective height of the column was almost 1.1 meter. And a gas flow rate with a blower was supplied with a flow rate of 11 cubic meter per minute. The stripper here, or the column here, had a design flow rate of 1.2 liter per minute. So what we found was for the MAP struvite, almost 1-to-1 ratio was found to be the most optimum or the highest recovery rate. As of pH, for the struvite, for the MAP struvite, 10 was found to be the optimum pH. And for mixing time, 30 minutes and 45 minutes were to be optimum. So for the recovery, phosphorus was managed to be recovered for both cases, more than 90%, ammonium more than 80%, and potassium was almost more than 25% recovery was achieved through this research. And in addition, we have also tried to verify the formed crystal, whether it's struvite or not, using the XRD analysis. So what's the way forward for our research team? Even though we tried to simultaneously recover all the three nutrients at the same time, we couldn't handle that, we couldn't do that, because potassium could not be simultaneously recovered with ammonia. So what we are planning now is we are trying to collect the nitrogen in the urine so that we don't lose it through the stripping process. And another phase of the project or phase of the study would be recovering nutrient from anaerobic digested reject water. So this water is expected to be collected from the only centralized wastewater treatment plant in the city, in the capital city. So this treatment plant is a UFB followed by trickling filter. So we're trying to collect a sample and see whether nutrient recovery, specifically struvite, is possible or not. So thank you.
Great, thank you very much. We have time for questions now as well. And while people have a chance to, oh, here we go. Here's one in the comments. The question is, can we use dolomite lime for struvite?
Instead of the magnesium chloride?
I assume that's the meaning, yeah. The question just is if you can use dolomite lime for struvite.
We didn't try that, but instead we tried to use a brine water instead of the magnesium chloride. That's actually under progress. We don't have any result for that.
I had a question for you, which was one of the slides mentioned potassium struvite, I believe, and I wondered if you could elaborate more on if you were able to form that and how you did that.
The potassium struvite was extracted by stored urine with ammonium stripping, which we have constructed in a laboratory, a column constructed. So the urine was trickled down the column constructed there, and we tried to minimize or to remove the ammonium out of the urine. Then the potassium come into picture and the crystal formed.
Okay, we have one more question here from Steve Jones. What does the final form of the struvite look like?
For the map case, it was solid, a well-formed solid material. But for the potassium case, we needed to use an oven to dry up the crystal. It was not that easy.
Great, well, thank you very much, and good luck with the continuation of that research.
Thanks.